I wish I could be a genius.
What are you talking about? But there is a way for ordinary people to beat a genius.
Don't tell me it's just about hard work.
It's about everyone sharing their ideas.
That sounds pretty basic. But even if you gather a bunch of average people's ideas, they'll still be average, right? In fact, wouldn't it just cause more confusion?
It's understandable to think that way. But actually, there are cases where the conclusions drawn by an ordinary group are better than those drawn by a single genius.
Really?
Today, I'm going to explain the Diversity Prediction Theorem. It all started in 1906 in the UK. A livestock exhibition was held in the port city of Plymouth. At the exhibition, there was a contest to guess the weight of an ox, and about 800 people participated.
Guess the weight of an ox?
Yes, everyone would guess the ox's weight, write it down on paper, and the person closest to the actual weight would win a prize. The participants ranged from livestock farmers and butchers with expert knowledge to people who were just gambling enthusiasts or knew nothing about cattle but thought it would be fun to participate.
So there were both experts and complete amateurs.
Eventually, the results were announced. The correct weight of the ox was 1,198 pounds. The closest guess was from a livestock farmer who guessed 1,207 pounds.
So the person with expert knowledge won. I guess it's hard for an amateur to guess the weight of an ox.
Here's where it gets interesting. Among the participants was a scientist named Francis Galton. His field was eugenics. He was the first scientist to propose eugenics to the world.
What's eugenics?
Eugenics is the idea of improving the human race by selective breeding, eliminating harmful genetic traits, and evolving the species.
That sounds dangerous.
Galton had some pretty extreme beliefs. He believed that only people from superior bloodlines had trustworthy intelligence, and he wanted to prove it.
I see.
So, he got the predictions of all the contest participants from the organizers and calculated the average. He expected that mixing the guesses of experts with those of complete amateurs would result in an average that was far off the mark. In other words, he wanted to prove that opinions from the ignorant masses should be dismissed. But the result was different. Galton was surprised by what he found. The average guess of all participants was 1,197 pounds, just 1 pound off from the actual weight.
Wow, that's amazing.
This surprising discovery by Galton has been verified many times since. For example, in 1987, an economist named Professor Traynor at the University of Chicago conducted an experiment. He asked 56 students to guess the number of jelly beans in a jar just by looking. The actual number was 850, and the average guess of the students was 871, just 21 beans off. There's also an American quiz show called Who Wants to Be a Millionaire? In this show, one person answers multiple choice questions. The actual contestant's correct answer rate is about 65%, but when the audience decides by majority vote, the correct answer rate is an impressive 91%. This phenomenon, where group predictions outperform individual ones, is called the Diversity Prediction Theorem.
Why does this happen?
Let's break it down mathematically. The error of a group's prediction is the square of the difference between the average prediction and the correct value. When you calculate this, the error ends up being the average individual error minus the variance.
What's variance?
Variance is a measure of data spread, which represents diversity. The more people differ from the average, the larger this value becomes.
Huh? Why does having more people with differing opinions reduce the average error? Aren't these the ignorant masses Galton was talking about?
Actually, no. In the case of the ox weight guessing contest, each participant made an independent prediction. So, some people overestimated the weight, while others underestimated it. As the number of predictors increases, the overestimations and underestimations balance each other out, resulting in a final average that's close to the true value. This is the essence of what's called the wisdom of the crowd.
I see, that makes sense. The wrong opinions of the ignorant masses are cancelled out by diversity, and the group's conclusion ends up being correct.
Let me explain this intuitively. Imagine an electoral district where 100% of the voters are ignorant. It's a single-member district with a two-party system. In this case, the ignorant voters vote randomly, so each party receives 50% of the votes. In other words, policies are chosen randomly. It's a parable about how democracy can't work with a population of ignorant people.
I see.
Now, imagine a district where 99% are ignorant people, and 1% are sensible people. Again, the ignorant voters vote randomly, so each party gets 49.5% of the votes. The 1% of sensible voters will decide the outcome, so the reasonable policy chosen by that 1% is what gets implemented. In other words, even if most of the group lacks special knowledge, as long as a small percentage of sensible people are present, democracy doesn't turn into mob rule. This is known as the miracle of the aggregate.
I see. This explains why a group's conclusion can be correct. Does this miracle of the aggregate also apply in real politics, according to the Diversity Prediction Theorem?
There's an interesting consideration regarding that. According to economist Brian Kaplan, the Diversity Prediction Theorem often doesn't apply in real politics. However, in the stock market, the theorem works astonishingly well, leading to prices being consistently set at their fair value.
Why does it work in the stock market but not in politics?
It's due to the difference in the cost of a vote.
What do you mean?
In elections, the opinions of a few highly motivated voters can heavily influence others. Media, big corporations, or special interest groups can sway the opinions of other voters. So, in elections, the masses aren't just random, they're biased.
Is diversity really that important in a group? I still don't quite get it.
Let's go back to the calculation from the Diversity Prediction Theorem. If everyone in a group completely agrees with one person's opinion, the variance becomes zero, and the group's error equals that of the individual. This eliminates the advantage of being in a group.
So, does that mean traders in the stock market, where the theorem works, tend not to be influenced by others? I find it hard to believe there's that much difference between traders and voters.
In the stock market, acting irrationally has a high cost. If you lose in the stock market, it's your money on the line. So, everyone acts selfishly, and that leads to diversity. In voting, however, acting irrationally costs almost nothing. You don't lose any money, and since your vote is one among hundreds of thousands, the value of a single vote is low.
I see. So there are conditions for the Diversity Prediction Theorem to work.
Exactly. Specifically, there are 4 conditions: diversity, independence, decentralization, and aggregation.
What do those mean?
Diversity means that each individual has some unique private information. It implies that not everyone has the same prior knowledge or thought process. The second condition is decentralization. Each person has to have some level of expertise and needs to make their own judgments. Basically, these 2 are the conditions needed to maintain diversity within the group. The third condition is aggregation. There must be a mechanism to aggregate individual opinions into a single decision, like in elections or the stock market.
Right. No matter how many opinions there are, without a system to summarize them, you can't get an answer.
However, even if these 3 conditions are met, there are cases where a group's diversity isn't maintained. That's the fourth condition, independence, meaning not being influenced by others' opinions.
Even if everyone has different opinions, if there's a dictator-like person who dismisses them, it's meaningless.
According to American sociologist Scott Page, a wise crowd turns into a foolish mob when independence isn't maintained. This is often seen in politics, or in stock market bubbles, which happen because people get too influenced by others when buying stocks. That's the difference between theory and reality. That's why in the real world, the wisdom of crowds often doesn't work as well as expected. To summarize, diversity has 2 powers. One is the ability to cancel out individual errors, as seen in guessing the weight of a cow. The other is the power to amplify the influence of wise individuals, as seen in demagoguery.
So these 2 forces are what make up collective intelligence.
That's the end of the explanation.
A diverse crowd can predict more accurately than the average individual. That's what diversity prediction theory is about.
To be precise, a group's predictive ability consists of individual ability and group diversity. So, being diverse is actually just as important as having high individual ability.
You could say that having a diverse group is extremely valuable. Being different from others is as important as having high individual ability.
So, that's all for today. Thank you for watching.
See you next time.